ሄሎ ሄሎ ሲሳይ አይሰማም። አይሰማም አይሰማም።
ሄሎ ይሰማል?
ሄሎ ይሰማል? ይሰማል?
ዲስፕሌይ ሆኖላችኋል?
አልሆነልኝም።
አሁንስ
ይሰማል? አይታይም አይታይም። አሁን ይታያል።
ኦኬ اوكي نجمر.
نجمر. ትንሳኤ ቢ የሚለውን ሚስ ማድረግ ስላለ ወይ እዛ ጋር ሚስ ለማድረግ አንተ ራስህ
ምን የሚለው
ቢ የሚል አንድ ሜምበር አለ። አዲስ ዩኒቨርሲቲ ሎጎ ቢን ሚውት አድርገው። ኦኬ ሚውት ሆነ።
ኦኬ
ሻው መጀመር እንችላለን።
Okay, this is a biochemistry part for module 4. That is basic concepts of disease therapy. In this module, we will see definition and source of free radicals, and also we'll see also type of free radicals. And later, if time permits, today we'll see antioxidants. We'll see exogenous as well as endogenous antioxidants. And finally, tomorrow we'll see oxidative stress and damage in disease which is caused by free radicals. Therefore, at the end of these sessions, you'll be expected to describe the major reactive oxygen species and their sources as well. And you'll be able to identify targets of reactive oxygen damage, and you will see the effect of reactive oxygen species on biomolecules. And the other objective, which is expected to achieve today, is you'll identify the major role of antioxidants. It can be enzymes or it can be coenzymes. We'll see this one. And the other is you'll be able to explain the role of reactive oxygen species on development of chronic as well as inflammatory disease. First, let's see what free radical means. Or let's see the definition of free radicals. In chemistry, free radical is any atom or any compound which will have unpaired electrons on the outer orbitals. This is called a simple definition of free radicals. Free radicals can live independently, but it should have what? More unpaired electrons on the outer orbitals, and symbolically can be denoted as superscript dot, that is it is represented as R dot. As usual, you know, oxygen is the last electron acceptor during electron transport chains. And when oxygen is fully reduced, it will be changed into water. But since the electron transport chains accepts not two electrons, rather than it accepts one electron due to iron sulfur clusters, in this case, reactive oxygen species can be produced, mainly in electron transport chain or mainly in complex 1 and complex 3. Free radicals can be generated within the mitochondria. This is before dealing with how free radicals can be generated in our body, first let's see the terms on redox chemistry. One, oxidation means it is simply gain of oxygen, or it can considered as a loss of hydrogen or loss of electrons, whereas reduction is the opposite of oxidation. And the terms which is used in this session is one is oxidant. Oxidant is any substance. It can be considered as an oxidant. It can oxidize another chemicals by taking electrons or by taking hydrogens, whereas the opposite can be done in reductant compounds. Before doing that, compounds can be considered as pro-oxidants. These compounds can generate free radicals, okay? And these free radicals can be toxic. It can affect our biomolecules. It may affect our plasma membrane, or it may affect our proteins. It may affect our DNA and may lead to cancers. These are considered as pro-oxidants. Any compounds which are capable of forming reactive oxygen species are considered as pro-oxidants, whereas free radicals are any substance which exists independently, but it should have what? One or more unpaired electrons on the outer orbitals. Free radicals can be different types. even if a compound can be non-radical, but it can be grouped under free radicals. This is because it can, even if the substance is not as such, it has not have any free radicals or unpaired electrons on the outer orbitals, but it can able to generate what? Other forms of free radicals, or it can initiate a formation of reactive oxygen species. In this case, this such type of molecules can be considered as non-radicals, species that have a strong oxidizing potential, like hydrogen peroxides. Free radicals can be different types. It can be carbon-centered, it can be nitrogen-centered, oxygen, or sulfur-centered. Non-radicals like hydrogen peroxide, okay, singlet oxygen, peroxynitride, and so on. And these free radicals can be two types mainly. It can be reactive oxygen species, okay, like radical forms like peroxide, mainly it's produced under mitochondria due to leak of electrons under electron transport chains. But what is expected from you is that here you should know what? Which form of reactive species is abundant in our blood, and the other is which form of reactive oxygen species are the most toxic. Okay? And the other group of reactive oxygen species are, or the other form of free radicals are, reactive nitrogen species. Reactive nitrogen species like nitric oxide, okay, like nitrogen dioxide, are radicals. We do have another form of reactive nitrogen species like non-radicals, which has nitrogen centered, are considered as reactive nitrogen species. Sometimes free radicals can be oxygen centered as well as nitrogen centered. Such type of molecules are called reactive nitrogen oxygen species, like peroxynitride and so on. What are the major characteristic features of free radicals? One is independent existence. Okay, can be found independently, but it should have unpaired electrons, and they are extremely reactive. Okay, it should have short lifespan. It can initiate or generate other form of reactive oxygen species through chain reactions. And the other characteristic feature of free radicals is that it can damage what? Biomolecules, cells, or various tissues. These are some of the characteristic features of reactive oxygen species. One is superoxide radicals. For example, it is symbolic as O2 minus dot. It's considered as poor oxidant, but here what is expected from you is that you should know which one is the most reactive oxygen species, or which one is the most extremely toxic to our biomolecules. The most extremely toxic form of reactive oxygen species is hydroxyl radical. Okay? Hydroxyl radical, OH dot, is extremely reactive, but it diffuses only to very low distance. Whereas hydrogen peroxide, it will have a different phase of hydrogen peroxide. It can persist up to minutes, and it can cross our cell membranes. Here, what is expected from you is that when oxygen is excited, it can able to form what? Singlet oxygen. This can be considered as reactive oxygen species, and it can be considered as powerful oxidizing agent. But here, what is expected from you is that the most toxic and reactive oxygen species, hydroxyl radicals, but its effect will be limited. Okay, it is time dependent, since it will diffuse only in short distance. Longitude, when is the longitude?
ሄሎ
Yes. አይሰማም?
ይሰማል። ተማሪዎች መግባት ፈልገው ነበረ።
Okay. Sure. Okay, when you see the lifespan of reactive species, some may stay up to minutes, like as I mentioned earlier, hydrogen peroxide, and the hypochlorous acids. Mainly it is formed during respiratory burst. The other is peroxyradical nitric oxide. It can persist up to seconds. Whereas hydroxyl radical, that is the most toxic form of free radicals, the lifespan is within nanoseconds. Now, how reactive oxygen species affects our biomolecules through different radical mediated reactions. One is through addition. Okay, it can able to form or it can initiate other form of free radicals, or through hydrogen abstraction, it can generate other form of radicals, or sometimes reactive oxygen species can damage our biomolecules through electron abstractions. Sometimes when two reactive oxygen species can react together to terminate formation of reactive oxygen species, or sometimes by through disproportion or dismutations, there is termination of reactive oxygen species propagated. For example, if you see how free radicals affect our DNA, one, the hydroxyl radical is the most toxic radical. These hydroxyl radicals, through addition reactions, it may able to form what? DNA adduct. That is, it can able to form what? 8-hydroxyl deoxyguanosine. The other is hydroxyl radicals can undergo hydrogen abstraction from our DNA, and it will able to form what? DNA strand breaks. This leads to different mutations, and finally it will lead to cancer.
كده
Now, yes,
عندي እንደገና ተማሪዎች እየጠየቁ ስለሆነ
አሉ የሉም። አሁን እዚህ ጋር ለመግባት ሁሉንም
የጠየቅ የለም።
አደረጋቸዋለሁ።
ኦኬ እሺ
እሺ። Now, this reactive oxygen species as well as reactive nitrogen species may able to react together to form another form of what? Reactive nitrogen oxygen species. Example, during electron transport chains, as shown from this picture, during electron transport chains, oxygen is the last electron acceptors, and mainly complex 1 and complex 3 can produce large amount of superoxides. This is due to when electrons are transported to the final electron acceptor oxygen, rather than transporting two electrons at the same time, due to the presence of iron sulfur clusters, it will accept what? 1 electrons. In this case, it may leak electrons and react with oxygen. It can able to form what? Superoxides. Now, superoxides can be produced. This is one form of reactive oxygen species. Can react with nitric oxide. As you know, nitric oxide can be synthesized in our body from L-arginine by nitric oxide synthase. It can be indissoluble. Okay. We do have 3 types of nitric oxide synthase isoenzymes. In inducible nitric oxide synthase, it's not as calcium calmodulin dependent, rather than the enzyme activity is dependent at gene transcription levels. And when these enzymes are induced, large amount of nitric oxide is produced. This nitric oxide reacts with superoxide. It can able to form what? Or it can able to generate other form of reactive nitrogen oxygen species like peroxynitrile and so on. Okay, this is how reactive oxygen species reacts with reactive nitrogen species. But even if reactive oxygen species can affect our biomolecules, our cells, our tissues, it has its own role at physiological levels. One is the positive effect of reactive oxygen species to our bodies is that it can kill microorganisms during inflammations or during pathogens, or if any bacteria attacks our body. Reactive oxygen species can be generated by respiratory systems, and it can kill microorganisms. The other is mainly among reactive oxygen species, hydrogen peroxides can act as secondary messengers. As you know, cyclic AMP, cyclic GMP, calcium, and so on, can act as secondary messengers. Just like that, hydrogen peroxide can also act as what? Secondary messengers to enhance cellular differentiation as well as propagation. And it can also regulate signal transduction as well as gene transcription through different receptors or signal transduction pathways, through receptor tyrosine kinase, through protein tyrosine phosphatase, or it can be through serotonin kinase. Reactive oxygen species can act as what? Secondary messengers to do or to decide the final response. These are some of the physiological roles of reactive oxygen species. For example, it can kill microbes, okay, through phagocytosis. It can also determine cell differentiation as well as development. It can also be important for iodination of tyrosine and tyrosine biosynthesis. Reactive oxygen species also promotes growth of fibroblasts. Collagen therefore helps in wound healing. Okay, some of the reactive oxygen species can be useful for wound healing. Some of the reactive oxygen are also important for mucus production as well. Okay. Now let's see how free radicals can be generated. Okay. You have two sources. One is endogenous, the other is exogenous source. Through cellular metabolism, for example, let's say endogenous sources. Always, as you know, oxygen is the last electron acceptor. Since it has high redox potential, can accept electrons and it can be converted into water. But about 1 up to 4% of oxygen taken up in the body is converted to free radicals. This is average radical production normally under normal individuals. Always there is free radical production. They are constantly produced during normal oxidation of foodstuffs. This is due to lack of electron transport chain in the mitochondria, mainly complex 1 and complex 3. Some enzymes, such as, for example, xanthine dehydrogenase, okay, when there is high amount of oxidative stress is there in our bodies, xanthine dehydrogenase can be changed into xanthine oxidase. And this xanthine oxidase also produce other form of reactive oxygen species. The other is always free radicals can be produced using macrophages. Macrophages also produce nitric oxide from enlarging through nitric oxide synthase. This can have its own role as antibacterial mechanisms. The other is since human beings can be exposed to different environmental factors due to xenobiotics, reactive oxygen species can be produced mainly in phase 1, or if someone exposed to UV light or X-ray, there is production of reactive oxygen species. If someone takes alcohol, okay, those enzymes resides on the microsomal. If you take excess amount of alcohols, these enzymes are induced and it can generate what? Large amount of free radicals. Smoking also can generate source of free radicals. These are a summary of how free radicals can be generated endogenously. Okay. There is production of hydrogen peroxide and superoxide by xanthine oxidase and NADP oxidase due to membrane lipid peroxidation. As you know, unsaturated fatty acids within the plasma membrane is highly susceptible for lipid peroxidation. Whenever there is lipid peroxidation, there is production of free radicals. The other is using peroxomes, there is large amount of production of hydrogen peroxide as well as superoxides. During prostaglandin synthesis as well, free radicals can be generated. Once prostaglandins can be synthesized from arachidonic acids due to the presence of cyclooxygenase 1 and 2, there is production of free radicals. The other is there is production of nitric oxide from arginine by nitric oxide synthesis during phagocytosis, during heme to bile pigment oxidation, can be performed free radicals. Even and normally through auto-oxidation of mainly transition metals, there is production of what? Free radicals. The other source is exogenous source due to drug metabolism. As you know, in the last module, we have seen cytochrome P45 enzymes. There is production of what? Free radicals, mainly at phase 1. If someone is exposed to X-ray or UV light, may be able to generate reactive oxygen species. Even if oxygen is excited, the photolysis can generate free radicals. Cigarette smoke, alcohol, as you know, taking alcohol can generate free radicals, and this promotes what? Lipid peroxidation. This is a summary how free radicals can be generated. This is where reactive oxygen species and reactive nitrogen species can be produced. Within the cytosol, due to the presence of transition metals, if these transition metals should be sequestered within the proteins, but if it's leak out, can able to react with another form of reactive species and to produce other form of reactive oxygen species. Within microsoma, if the presence of cytochrome P450 enzymes, reactive oxygen species can be generated using endoplasmic reticulum. Within the mitochondria, due to electron transport chain, large amounts of free radicals can be generated, mainly superoxides. Within the plasma membranes, due to lipid peroxidation, the presence of lipoxygenase, as well as NADP oxidase, or due to the presence of prostaglandin synthase, free radicals can be generated. Within the lysosomes as well, free radicals can be generated. And in our body, various factors can elicit the production of reactive oxygen species. If there is stress, large amount of reactive oxygen can be produced. If there is a deficiency of antioxidant enzymes, there is production of reactive oxygen species will be increased. If there is inflammation, large amount of radicals can be generated. If there is mitochondrial dysfunction, as well, large amount of free radicals can be generated. Or if you are exposed to UV radiation, large amount of free radicals can be produced. Even angiotensin 2 using smooth muscles can able to generate what? Free radical formations. Now, these are the major source of reactive oxygen species in vivo within our bodies. We mentioned most of them, but finally, here non-enzymatic reaction also one of the major source of reactive oxygen species in our bodies. It's first endogenous source, how free radicals can be generated within the mitochondria. We do have different type of complex. Okay? Complex 1, complex 2, complex 3, complex 4. Among these, almost most of them can produce free radicals, but mainly in complex 4, like cytochrome C oxidase. Even if free radicals can be generated, but it will not leak out from the complex. Okay. In complex 2, it's such a small amount of free radicals can be generated. But here, complex 1 and complex 2 can generate what? Large amount of free radicals, mainly in the form of superoxides. But under what conditions reactive oxygen species can be produced within the mitochondria? Mainly if there is high amount of NAD rather than NAD+. This stress electron transport chain and damages the mitochondria, and it will produce large amount of free radicals. The other is if our mitochondria will not make ATP, large amount of free radicals can be produced, since most of the electron carriers are fully reduced. This is how free radicals can be produced in the mitochondria, and these free radicals can attack the membrane of the mitochondria, and there is lipid peroxidation, This may release cytochrome C. Okay, this enhances what? Apoptosis or necrosis, and finally it will lead to mitochondrial dysfunction as well as disease, and there is unbalance between redox signaling, and it may lead to what? Aging. The other is during phagocytosis. Okay, if bacteria attacks us, there is rapid increase of oxygen consumption by phagocytosis using the lysozyme. This is followed by what? Large production of reactive oxygen species, which are enzymes are responsible for respiratory burst, like NADPH oxidase and myeloperoxidase. Here, when NADPH reacts with oxygen through NADPH oxidase, okay, that is sometimes called NOx. NADPH oxidase is sometimes called NOx, NOx. It can be different types of isoforms. And here, NADPH can generate what? Superoxides. When these superoxides reacts with, or these two superoxides reacts together, it can able to generate what? Hydrogen peroxides. When these hydrogen peroxides reacts with superoxide as well as chloride ions by the presence of myeloperoxidase, hypochlorous acid can be generated. Okay? This can kill what? Bacteria. Phagocytosis can be takes place within the neutrophils and the macrophages in order to ingest bacteria, and this is a means of mechanism of immune response to inflammation. In this case, using respiratory burst, there is a step increment to oxygen consumptions. These oxygen consumptions can be utilized by specific enzymes like NADPH oxidase, and this generates superoxides. These superoxides, through these mutates, okay, can be through the activity of superoxide dismutase, or normally one superoxide reacts with another superoxide spontaneously without any help of enzymes. It can able to generate what? Hydrogen peroxide. And when hydrogen peroxide reacts with chloride, it can able to generate what? Hypochlorous acids. And this is toxic. It's catalyzed by myeloperoxidase. It can able to kill the bacteria. If there is a mutation in NADPH oxidase, as I mentioned earlier, the synonymous name of NADPH oxidase is NOx. If there's any mutation of the genes which are able to synthesize this enzyme, individuals may develop chronic glomerular disease. This is because there is diminished production of superoxide ions and other derivative of reactive oxygen species that diminish of killing certain bacteria that enhance recurrent infection. The other enzyme is xanthine oxidase. Okay? The other enzyme which can able to generate reactive oxygen species endogenously is xanthine oxidase. Initially, we do have an enzyme called xanthine dehydrogenase. As I think you know how purines can be metabolized in our bodies. Okay? When adenine and guanines are metabolized, detoxified, or degraded in our bodies, uric acid can be produced. And when uric acid is produced, the main enzyme which is responsible for purine degradation is xanthine oxidase. But initially, we have xanthine dehydrogenase, okay, which uses NAD plus electron acceptor. But whenever there is a high amount of reactive oxygen species is present in our body, xanthine dehydrogenase, it can be oxidatively modified and it can be transformed to xanthine oxidase. But unlike that xanthine dehydrogenase, xanthine oxidase will not use NAD+, rather it uses what? Oxygen. And this oxygen can be useful to generate what? Free radicals like hydrogen peroxide, like superoxides, and so on. This is how xanthine oxide generates what? Reactive oxygen species. The other, we will see later how free radicals can be generated non-enzymatically by autooxidation of hemoglobins or through Fenton reactions. in Fenton reactions, we should know the importance of the important role of transition metals. The other enzyme which is useful for synthesis of reactive oxygen species, nitric oxide synthase. We do have three forms of nitric oxide synthase. One is endothelial, the other is inducible, and the other is neuronal. Both inducible nitric oxide synthesis, it's not such calcium dependent, but the rest are. Their activities managed through calcium calmodulin. Without calcium, endothelial and neuronal nitric oxide synthesis are inactive. But calcium will not affect inducible nitric oxide synthase. The enzyme activity of nitric oxide synthase is managed at gene transcription levels. Both endothelial as well as neuronal nitric oxide synthase produce low amount of nitric oxide, and whereas inducible nitric oxide synthase produce what? Large amount of free radicals, and its activity will not be regulated by calcium. Rather, as I mentioned earlier, it is regulated by gene transcription levels. You know the function of nitric oxide, yeah? Nitric oxide can protect our endothelium. This is because nitric oxide, just like that of prostacyclin I2, it has its own role in vasodilation effects. When there is nitric oxide, as you know, nitric oxide can act as a gas in neurotransmitter. It can pass the plasma membrane, and it can bind with guanylyl cyclase within the cytosol. And guanylyl cyclase, initially it is inactive. When nitric oxide binds with it, the enzyme becomes active and changes GTP into cyclic GMP. And you know the role of cyclic GMP, it will dilate the blood vessels. That means we have seen initially, how reactive oxygen species reacts with reactive nitrogen species. Superoxide will react with nitric oxide to form peroxynitride. That means when there is oxidative stress, the amount of nitric oxide becomes what? Very less, because there is high production of superoxides. This superoxide reacts with nitric oxide. It can generate other form of reactive oxygen species. That's the first initial symptom of atherosclerosis. Okay, during atherosclerosis, the amount of nitric oxide becomes what? Less. That means whenever there is high amount of free radicals, individuals are highly prone to develop cardiovascular disease, or his heart can be attacked. Nitric oxide is very important for acid molecules, can act as vasodilator, neurotransmitters, or it can mediate immune response. But nitric oxide is a precursor for other reactive nitrogen species. Okay. There may be what? Pathological modification. Their concentration may be decreased under oxidative stress. These are the three major enzymes which is responsible to form nitric oxide. Both neuronal as well as endothelial are calcium dependent, and their production of nitric oxide is, their concentration is as such not significant. Okay, when our body needs, nitric oxide can be synthesized. Whereas inducible nitric oxide, their amount of synthesis can be very high. Okay. Once reactive nitrogen species like nitric oxide reacts with superoxides, can generate what? Peroxynitride. And this peroxynitride is a powerful oxidant because it can oxidize as the amino acid residues within the protein. But it may have also a role in antimicrobial effect, mainly within the macrophages. The other source of reactive oxygen species endogenously is within the peroxisomes. Okay? Peroxisomes can generate large amount of free radicals like hydrogen peroxide, and so and with the presence of catalyst, hydrogen peroxide can be changed into water within the peroxisomes. But peroxisomes are It is source of free radicals. Can generate hydroxyl radical, it can generate hydrogen peroxide, it can generate nitric oxide, peroxynitride, and so on. These are some of the enzymes which listed using the mammalian peroxisomes that generate reactive oxygen species. Even during prostaglandin synthesis, okay, like eicosanoids, you know how eicosanoids can be generated. Okay, using prostaglandin synthesis, prostaglandin H synthase can act as source of reactive oxygen species. And within the lysosome, okay, within the lysosome, reactive oxygen species also produce like hypochlorous acid and so on. You know the role of myeloperoxidase. It can generate other form of free radicals within the macrophages that can affect our biomolecules. It can enhance lipid peroxidation. Okay. It can form other adducts by formation of protein cross-links that may lose the function of the original role of proteins. Even microsomes can act as a source of reactive oxygen species. Okay. Within the endoplasmic reticulum, as you know, we do have cytochrome P450 enzymes. These enzymes are useful for drug metabolism or any form of xenobiotic metabolisms. Within phase 1, large amount of free radicals can be generated. This how drugs or any form of metabolism, any form of xenobiotics can be metabolized under our body, mainly within the liver. And the liver is highly prone to be attacked by free radicals. The peroxides can be generated. Having these free radicals, we need to take what? Antioxidants, mainly exogenous sources. Or you can enhance your antioxidant enzymes, okay, through exercise in order to scavenge or destroy those free radicals which is produced under phase 1 drug metabolism. The other form of reactive oxygen species which is generated in our bodies are during quinone redox cycles. We have seen already, quinone can accept 2 electrons, but 1 electron at a time. In this case, it can able to form what? Free radicals. The other is non-enzymatic source of generation of reactive oxygen species. One is Penton reactions. When iron 2 plus, it's a ferrous form, is highly reactive and sequestered within the proteins. But the presence of these transition metals will react with hydrogen peroxide. It can able to generate what? Hydroxyl radical. The most reactive oxygen species can be generated by non-enzymatic. The other is Haber-Wilson reactions. In this case, when superoxides react with hydrogen peroxide, can able to generate hydroxyl radicals. Even peroxyline production can be produced non-enzymatically. When superoxide reacts with nitric oxide, it can be able to generate peroxynitride. And even through alpha-oxidation of hemoglobin, free radicals can be generated. Okay. And when there is high amount of glucose in our bodies, that enhance glucooxidation. This is then non-enzymatically reaction of saccharides, which binds with protein, and the product will be advanced glycation end products. And the presence of high amount of advanced glycation end products will enhance more production of oxidative stress to our bodies. And how hydroxyl radicals can be generated? Mainly by Fenton and Haber's reactions. And here, what you should know is that the importance of transition metals. And since the ferrous form of iron, is extremely reactive oxidant and reacts with other form of reactive oxygen species, can generate the most extremely powerful reactive oxygen species, that is hydroxyl radicals. By any means, initially iron plus 2 is sequestered within the protein, but by any means, if this iron is leaked out from the protein, it will enhance what? Production of large amount of reactive oxygen species. And the other source of free radicals is that it can be generated by exogenous source, through radiation, through chemicals, okay, or some chemicals, or it can be drugs. It may enhance what? Production of superoxide formations. Even when drugs can be metabolized in our body, it may generate also free radicals, or any chemicals, which release iron from a protein in the form of iron 2 plus, that also enhance free radical formations. Or if someone exposed to smoking cigarette, production of reactive oxygen species can be increased. Excess consumption of alcohols, exposure to fungal, viral, bacterial infection. There may be what? Acute inflammation. This acute inflammation enhance production of large amount of reactive oxygen species. This is how exogenous sources can produce reactive oxygen species. If someone will undergo radiotherapy, okay, or if someone exposed to X-ray radiation, his body can produce reactive oxygen species. And formation of such type of production of reactive oxygen species in our bodies are considered as exogenous. Quinone, as I mentioned earlier, it is one mechanism of generating reactive oxygen species. And some therapies, okay, some hormonal therapies can be synthesized by having large amount of quinones. And when someone takes or someone undergoes hormone therapy, okay, mainly hormone replacement therapy, his body can produce large amount of free radicals since it has the hormone replacement therapy composition has an amount of quinones. Chemicals also enhance production of reactive oxygens like peroxidase, like ozone, like singlet oxygen, and enhance production of other form of reactive oxygen species. Lower proteins, other drugs like PARP also enhance production of superoxides. Even some chemicals, okay, which can be exposed to. If someone exposed to these chemicals, his body will undergo detoxification of these chemicals within the liver. For example, benzene, it can be changed into phenoxyl radical. And these phenoxyl radicals can attack our bone marrow. And this leads to suppression of bone marrow production. This is how reactive oxygen species can be generated exogenously. Even some chemicals, whenever it is metabolized in our body, it can able to generate free radicals. These are considered as external source of generation of free radicals. As summary, we do have two sources of generation of free radicals. One is endogenous source, the other is exogenous source. Cellular source like enzyme reaction due to respiratory burst or due to a leak of electron transport in the mitochondria or through microbes or endoplasmic reticulums. Reactive oxygen species can be generated or through environmental factors. It's exogenous source. If someone exposed to UV light, X-ray, or to toxic chemicals or xenobiotics, large amount of production of free radicals can be generated. And free radicals can attack our biomolecules, our proteins, our lipids or DNA. To inhibit this, we need to have what? Antioxidants. Okay. Unless and otherwise, if you will not able to manage the concentration of reactive oxygen species, it may impair our physiological functions, and that may lead to what? Aging or different type of disease or made cancer. And we do have also biomarkers to indicate the concentration of reactive oxygen species in our body. For example, if you do have a high amount of reactive oxygen species, it may attack our DNA. Okay? Then when DNA is attacked by oxidative stress, there is production of deoxyguan. This deoxyguan can act as what? A biomarker to indicate there is free reactive oxygen stress. This stress indicates our DNA is affected. Sometimes, if there's oxidative stress, this oxidative stress also affects our proteins, and the protein will undergo oxidation, and the end product will be protein carbonate or nitrotyrosine. These are biomarkers to indicate there is oxidative stress. That means there is production of high amount of reactive oxygen species in our bodies, or there may have what? Less antibody defense system. If there is high amount of oxidative stress, there may have glycooxidations. This glycooxidation produces advanced glycated products. That is considered as a marker to indicate our carbohydrates are affected. Now, the other markers to indicate our lipids are affected with the presence of oxidative stress is malonaldehyde. Okay. If you do have questions, please welcome for part 1, that is source of free radicals and its definition. Yeah, ያላችሁ
ሄሎ
ይሰማል? ቀጥል።
ይቀጥል። ትንሽ አንዴ ቀን ጠብቁና ጥያቄ እስኪጽፉ።
እሺ፣ ወይም መጨረሻ ላይ ጻፉልኝ።
በቃ እንደሱ ይሻላል።
Now let's see the types of free radicals. Okay, we do have a different type of free radicals. One is oxygen centered, like singlet oxygen, superoxide, hydroxyl radicals, sulfur centered, carbon centered, nitrogen centered radicals. These are some of the types of free radicals. Mainly, it can be two types: oxygen centered or nitrogen centered. And these are some of the characteristic features of individual superoxides, individual reactive oxygen species. For example, if you consider superoxides, where superoxides are produced, superoxides are mainly produced due to electron transport chains, mainly in complex 1 and 3. And since superoxides will not diffuse far from site of production, their time or lifespan is small. But if reacts with other form of reactive oxygen species, it can generate other form of reactive oxygen species. The other hydrogen peroxide. Hydrogen peroxide, as I mentioned earlier, this is not as free radicals, but it can generate or initiate other form of free radicals when it will react with transition metals to Fenton reactions. The other is hydroxyl radical. This is the most reactive species in attacking our biomolecules. It can be produced from hydrogen peroxides in Fenton reactions in the presence of transition metals. The other is peroxyl radical. These are some of the individual reactive oxygen species. Now, we do have two sources of reactive oxygen species. One is endogenous, the other is exogenous. But when it's the mechanisms of formation of oxygen-free radicals can be generated by two mechanisms. One is through electron transfer reaction or through energy transfer reactions. Through electron transfer reactions, superoxide, hydrogen peroxides, hydroxyl radicals, and other form of lipid radicals like lipid haloxy, lipid peroxy radicals can be generated through electron transfer reaction. The other is oxygen-free radicals can be generated through energy transfer reactions. Like when oxygen is excited or gets energy, can be changed into single oxygen. And this single oxygen is considered as reactive oxygen species. And what are the targets, okay, of individual reactive oxygen species? First, for example, during electron transport chain, as you know, oxygen is the last electron acceptors. When oxygen accepts one electron, can be changed into superoxides. And these superoxides can be generated by the presence of NADPH oxidase or flavin or quinone. Superoxides can be generated. And superoxides will affect mainly iron sulfur clusters, or it may enhance release of iron. Next, when superoxides accept electron, it can be changed into hydrogen peroxide through spontaneous mechanisms or through the presence of enzymes like superoxide dismutase. And hydrogen peroxide also enhance the oxidation of metallo enzymes, or it may enhance the oxidation of amino acid residues within the protein, mainly cysteine and methionine. Now, when hydrogen peroxide reacts with chloride in the presence of pyroperoxidase, it may generate hypochlorous acid. When hydrogen peroxide accepts one electron, it can be changed into hydroxyl radical. And this can be generated by Fenton reactions. And hydroxyl peroxidase, this is the most reactive oxygen species, which can affect, it can able to affect our lipids, our DNA, and our proteins. Those amino acids which resides within our body proteins will undergo oxidation. These are some of the characteristic features of individual reactive oxygen species, how they are generated. Mainly, for example, superoxide anions, it's mainly produced by when oxygen accepts one electron within electron transport chain and within the mitochondria. The other hydroxyl radicals, this can be generated when superoxides react with hydrogen peroxide or through Fenton reactions. Hydroxyl radicals can be generated. The other is hydrogen peroxide. Hydrogen peroxide is produced by many reactions, but here what is unique, hydrogen peroxide is unique. It can be converted into highly damaging form of free radicals. It can be changed into hydroxyl radicals. But we do have an enzyme which decreases the effect of changing hydrogen peroxide into hydroxyl radicals. Before converting hydrogen peroxide into hydroxyl radicals, we do have an enzyme called catalase. It can change hydrogen peroxide into water. Okay, or sometimes hydrogen peroxide can be converted into singlet oxygen. Singlet oxygen, just like that of hydrogen peroxide, it's not has free radicals, but it can able to generate or initiate to produce other form of reactive oxygen species. When oxygen is energetically excited, it can jump 1 electrons and it can able to form singlet oxygens. And you should know here which one is the most toxic form of reactive oxygen species and which one is the most abundant reactive oxygen species. Here location is very important, okay? Within the mitochondria, superoxide is the most common. Within the blood, the other tissues, hydrogen peroxide can be present in high concentration. The most damaging, even if it will stay in nanoseconds, okay? The most toxic form of reactive oxygen species, the hydroxyl radical. Now, the effect of hydroxyl radical is determined by time. That means if once produced hydroxyl radicals, immediately if it will collide with other target biomolecules, these biomolecules can be affected. But if it's not collide with other biomolecules, their effect will be less, since the half-life time of hydroxyl radical is nanoseconds. These are, now let's see now individually reactive oxygen species. Okay, first let's see the source of superoxide radicals. Mainly it is produced within the mitochondria, but enzymatically other source of reactive oxygen species can be generated in our bodies, like xanthine oxidase, NADPH oxidase, cytochrome. These are enzymes which can generate superoxides. Cellular sources like macrophages, okay, mitochondrial transport, microsomal monoxygenase can able to generate superoxides. Environmental factors which able to generate superoxides like toxic chemicals, aromatic hydroxylamines, aromatic nitro compounds, paraquat is an insecticide. Even if someone exposed to chemotherapy agents like quinone, okay, like hormone replacement therapy, his body can able to generate superoxides. This is how superoxides can be generated within the neutrophils. NOx, as I mentioned earlier, it's NADPH oxidase. It uses NADPH and it will generate superoxides through receptor mediated reaction under smooth muscle cells in the presence of angiotensin II. Superoxides also generated. In both reactions, in addition to superoxides, hydrogen peroxide also generated. But in macrophages, okay, in addition to production of hydrogen peroxides due to myeloperoxidase, hypochlorous acid also produced. This is how superoxides can be generated. And the main source of superoxides are electron transport chain, cytochrome P450 enzymes in microsomal, mainly in smooth endoplasmic reticulum. And superoxides can be generated by specialized cells like macrophage leukocytes, okay? Or superoxides also generated when hemoglobin undergoes autooxidation. That means we do have also non-enzymatic source of reactive oxygen species. When transition metals like iron 2+ react with oxygen, can generate superoxides. Even whenever during catecholamines metabolism, when catecholamines reacts with water, it can able to form melanin plus superoxides. When reduced phelavin reacts with water, reacts with oxygen, it can able to generate superoxides. Even in the presence of coenzymes like coenzyme Q, mainly the Q-hydroquinone reacts with oxygen, it can able to form coenzyme Q as well as superoxide. Even tetrahydrobiopterin, when reacts with oxygen, can able to generate superoxides. Now, once superoxides are generated, what is the major role of superoxides? These superoxide radicals can be useful for immune response, okay, to kill the invading pathogens. The other is these superoxides can affect or can generate other form of reactive oxygen species. Therefore, you should limit the concentration of superoxides. Now, superoxides can be quenched by other superoxide radical scavengers, like superoxide dismutase, okay, can convert superoxides into hydrogen peroxides and water. Once superoxide dismutase changes superoxides into hydrogen peroxide, as you know, hydrogen peroxide is another form of reactive oxygen species. But this hydrogen peroxide can be changed into water through catalysis. Now, this is the mechanisms how superoxides can be generated. In respiratory burst, superoxides can be generated, but through this superoxides, through spontaneous or disproportion or dismutations, it can be changed into hydrogen peroxide. Or enzymatically, superoxides can be changed into hydrogen peroxide by superoxide dismutase enzyme. Okay. But superoxides also establish a pro-inflammatory state. Okay. Once if the concentration of superoxide radicals in your body is very high, that indicates or that enhances to establish pro-inflammatory state to your body. The presence of superoxides triggers the nuclear factor kappa B transcriptions. It also enhances endothelial cell damage. How? In biochemistry, you should know the mechanisms, okay? For example, if you do have a high amount of superoxides, how these superoxides affect endothelial cell damage? This is because in endothelial cells, if there is enough amount of nitric oxide and prostacyclin I2, that enhance vasodilation, okay? There is no vasoconstriction if there is enough amount of nitric oxide and prostacyclin 2. But the presence of high amount of superoxides, okay, diminishes the concentration of nitric oxide. How? High amount of superoxides reacts with nitric oxide and change it into peroxynitride. In this case, the concentration of nitric oxide becomes what? Diminished. Now, rather than vasodilation, it will enhance what? It will not keep its function of vasodilation. And that is the primary event of atherosclerosis. That is how superoxides establish endothelial cell damage. That enhances increased vascular permeability. It enhances neutrophil chemotaxis with the help of leukotriene before formation. It enhances lipid peroxidation. It enhances also DNA strand breaks. The other reactive oxygen species is hydrogen peroxide. How hydrogen peroxide can be produced in our body? One is spontaneous, through dismutation of superoxides. One superoxide and the other superoxide react together, unable to form hydrogen peroxides, or this reaction can be catalyzed by an enzyme called superoxide dismutase. Sometimes hydrogen peroxide can be produced by direct reduction of oxygen by the action of oxidases, like monoamine oxidase, glutathione oxidase, xanthine oxidase, and so on. Hydrogen peroxides also produced within the peroxisomes. Whenever there is oxidation of different organic substance, there is production of what? Hydrogen peroxide. Now, we have two sources. One is non-radical, that means enzymatic generation. Hydrogen peroxides can be generated. That means, in the presence of an enzyme, enzymes can generate hydrogen peroxides upon reduction of their co-substrates with that of molecular oxygen. Okay? Like NADPH oxidase, monoamine oxidase, and so on. Radical generation means the substrate is radical. Okay. Now, when two radicals can react together, it can form hydrogen peroxide. In the initial case, that's the non-radical. It means sometimes called enzymatic generation. The substrate is non-radical, but the presence of enzyme changes the substrate when it reacts with molecular oxygen. It can able to form hydrogen peroxide. Second one is radical generation or disproportion. That means when two superoxides react together, it's unable to form hydrogen peroxides even in the absence of enzymes. Now, what is the fate of hydrogen peroxide? We do have different type of fates of hydrogen peroxide. One is, let's see now some of them. One is catalase, myroperoxidase, glutathione peroxidase, and the femto reactions. In reaction one, what will be the fate of hydrogen peroxide in the presence of catalase? It will be changed into water. The other is what will be the fate of hydrogen peroxide in the presence of myroperoxidase in macrophages? Hydrogen peroxide will react with chloride ions. It can able to form hypochlorous acid. Okay? Or in the presence of alloy, in the presence of transition metals. Okay? Hydrogen peroxide reacts with iron 2 plus. It can able to generate hydroxyl radicals. Okay? The other, once hypochlorous acid is generated, as you know, hypochlorous acid is powerful oxidant and has high microbial activities. It can be generated during the respiratory burst to kill bacteria. Any superoxides that enter the cytosol of the phagocyte cells can be converted into hydrogen peroxides through superoxide dismutase. Once hydrogen peroxides are formed, this hydrogen peroxide, by using myroperoxidase enzyme, will have different fates. Okay? Can be changed into hypochlorous acid if there is myroperoxidase, or it can be changed into water if there is catalase. Now, hypochlorous acid, it is a bactericidal agent. Okay? But this acid can cause cell membrane, therefore can affect other tissues. That is, the presence of high amount of hypochlorous acid in your body indicates what? It may contribute to tissue damage, mainly during the inflammatory process. That means during inflammation, okay, or if there is acute inflammation may damage other tissues. Okay, or the presence of inflammation contribute to tissue damage. This is because high amount of reactive oxygen species like hypochlorous acid can be generated using the neutrophils. Okay. The other is the fate of hydrogen peroxide. The other fate is when the presence of glutathione peroxidase, it is selenium dependent enzyme. Hydrogen peroxide is produced when the presence of glutathione, in the presence of reduced glutathione and selenium, it can be changed into water. Okay, can be changed into water. The other fate is the Fenton reaction. Hydrogen peroxide, by Fenton reactions, it can able to generate other powerful reactive oxygen species, that is hydroxyl radicals. And iron 2 plus, that the ferrous form is more dangerous one. Okay? Since it will react with what? Hydrogen peroxide, and it can able to generate what? Hydroxyl radicals. Now, what is the significance of hydrogen peroxide? As such, it is weak reactive oxygen species. If the concentration of hydrogen peroxide is less than 50 micrometer, its toxic activity is very limited. Okay. Rather, hydrogen peroxide is considered as secondary messengers for signaling molecules. And hydrogen peroxide is a secondary messenger in nuclear factor capability activations. The principal enzyme charged with the removal of hydrogen peroxide in our bodies are catalase, ethiopian peroxidase, thyroid E. The other is hydroxyl radicals. We have seen how hydroxyl radicals can be generated. And this is formation of hydroxyl radicals in biological system can be done through ionization reaction, or reaction of metal ions, okay, transition metal ions with hydrogen peroxide, or formation of hydroxyl radicals from ozone. Now, how hydroxyl radicals can affect our biomolecules? It can affect through hydrogen atom abstraction, through addition, through electron transfer systems. Hydrogen peroxide can affect our biomolecules. Now, these are the source of hydroxyl radicals: endogenous source as well as exogenous source. If someone exposed to ionization radiation can generate hydroxyl radicals, or when there is transition metals react with hydrogen peroxide through Penton reactions, it can generate hydroxyl radicals. Okay, and here you should know the role of metal-dependent reduction of hydrogen peroxide. Okay, since it can generate hydroxyl radicals, and the most important transition metals which is useful to generate hydroxyl radicals are like copper, iron, cobalt, and so on. This is how hydroxyl reactions can be generated. And superoxide, as well as iron, plus their substrate for iron catalyzed harbors reactions, which also useful to generate hydroxyl radicals. And superoxides can release iron ions from ferrite that enhance formation of other more dangerous reactive oxygen species. And production of superoxides may be one of the major mechanisms involved in tissue injury due to iron overload. If there is iron overload, there is high chance of production of hydroxyl radicals. This is done in hemochromatosis. And you should know the role of transition metals. Okay, these transition metals should be what? Sequestered by proteins or chelators. Unless and otherwise, it can accelerate what? Non-enzymatic oxidation of molecules. And when you see the summary of hydroxyl radicals, this is the most potent species of reactive oxygen species. It can affect different biomolecules. It can affect our lipids, and lipids will undergo lipid peroxidations. It can affect our carbohydrates, and there is production of what? Advanced in the glycated products. And the more advanced in the glycated products in your body, that enhance more production of oxidative stress. And the other effect of hydroxyl radicals in our body is that those amino acid residues, okay, those amino acid residues which is found in our proteins will undergo oxidation, especially these aliphatic amino acids. And the product will be hydroxylation of tyrosine, hydroxylation of tryptophan, phenylalanine, and so on. And the other is hydroxyl radicals also affects our DNA. And DNA is mostly significantly damaged by the hydroxyl radicals, among other forms of free radicals. And as I mentioned earlier, among reactive oxygen species, hydroxyl radical is the most reactive and the most potent damaging species. And the presence of high amount of hydroxyl radicals in our body will have what? Will have high amount of biomarkers of oxidative stress. The more the concentrated hydroxyl radicals, that indicates there is what? Oxidative stress in your bodies. And how hydroxyl radicals affect our biomolecules? Primarily by hydrogen abstraction. And additional reactions will lead to form specific biomarkers that is useful as oxidative, that is useful to know the status of oxidative stress. One of the most sensitive sites for radical damage is, the cell membranes. Okay, and cell membrane is mainly composed from phospholipids, and when it's a composition of phospholipids, there is high amount of polyunsaturated fatty acids are present within the phospholipids, and the presence of double bond enhance the attack of free radicals. That means polyunsaturated fatty acids are more prone attacked by reactive oxygen species. Now, the high amount of reactive oxygen species in your body, it will enhance lipid peroxidation. This affects what? Our plasma membrane. It can affect integrity as well as function of plasma membrane. And this loses its function. And once plasma membrane loses some functions, there is inability to maintain ion gradient and then the phospholipid asymmetry. And the more hydroxyl radicals in your body will enhance lipid peroxidation. This lipid peroxidation affects what? Membrane damage. And there is protein modification. There is breakdown, or there may be what? Misfolding. And the other is the high amount of hydroxyl radicals will affect our DNA. That will enhance the mutation that leads to cancer. Now, when hydroxyl radicals abstracts hydrogen from polyunsaturated fatty acids, it initiates what? Lipid peroxidation. And this lipid peroxidation will induce to lipid peroxides and lipid peroxy radicals. And the end product of lipid peroxidation by hydroxyl abstraction of hydrogen from polyunsaturated fatty acids are maloldehyde and hydroxymonoamide. These are the markers to indicate the presence of lipid peroxidation by hydroxyl abstracts. And maloldehyde reacts with proteins, it can form what? Adducts. And the end product is known as advanced lipid oxidation end products, or ALA. When monoaldehyde reacts with protein, it will form what? Advanced lipid oxidation end products. And increasing level of MDA and ethiopian can adduct our lysine amino acid residues, which can be found within the lipoproteins in blood plasma, or within specific proteins in amyloid plaque. That means the high number of end product lipid peroxidation will affect the function of lysine amino acid residues in specific proteins. Now, quantifying these lysine adducts can be useful as a marker for atherosclerosis, or the marker in Alzheimer's disease, because there is high amount of lysine adducts by MDA in amyloid plaques, and measuring these adducts can be useful as a marker for presence of high amount of reactive oxygen species in Alzheimer's disease. This indicates there is implicated oxidative stress and damage in pathogenesis of this disease. The other is hydroxyl radicals also react with addition of phenylalanine tyrosine nucleic acid base, and it can form hydroxyl derivative and cross-links. For example, nitrotyrosine, like ALE, is increased in atherosclerosis as well as Alzheimer's disease. That means oxidative stress will have its own effect in chronic disease like atherosclerosis and Alzheimer's disease. These are some of the adducts which produce when there is hydroxyl radicals added to specific amino acid residues like phenylalanine, tyrosine, and so on. Now, how our bodies will prevent the effect of hydroxyl radicals to protect our biomolecules? One is through endogenous antioxidants like melatonin and glutathione. These are the endogenous antibiotics which is useful to reduce the concentration of hydroxyl radicals. The other is dietary antioxidants like phytochemicals and vitamin E. Okay, will have a good role to reduce the concentration of hydroxyl radicals. Since hydroxyl radicals are the most potent and damaging reactive oxygen species, but their effect will be what? Time dependent. since their half-life is nanoseconds. If there is no collision with biomolecules, they will not have such significant effect. Therefore, vitamin E and phytochemicals are important to reduce the concentration of this most toxic reactive oxygen species. The other is singlet oxygen. Okay? The other singlet oxygen, this is produced when electrolytically normal oxygen is excited. And singlet oxygen is a mutagenic form of normal oxygen. It's similar to that normal oxygen, but there is one difference since it has one additional extra electrons on the external orbitals. This radical is involved in different genes like arteritis and IDs. But how singlet oxygen is, concentration can be decreased in our bodies? Through antibodies, mainly vitamin A, vitamin E, can be useful to reduce the effect of singlet oxygen. The other is nitric oxide. As I mentioned earlier, nitric oxide can act as a gas, can act as a neurotransmitter. Okay? Previously, nitric oxide is named as endothelial-derived relaxing factors because we do have 3 specific enzymes which produce nitric oxide in our body. Among three of them, 2 of them is calcium dependent. Okay? In the presence of calcium carbonating, these 2 enzymes can be active, but the other, the unique one, is inducible nitric oxide synthase. These are calcium independent. Okay? Calcium will not affect the activity of these enzymes, but this enzyme can be regulated at gene level, at gene transcriptions levels. And you know the role of nitric oxide, why it's retained its name as endothelium-derived relaxing factor, because within the endothelium, once nitric oxide can be synthesized, since it is a gas, it can pass plasma membrane of our cells and can reach to cytosol. And within cytosol, we do have an enzyme called guanylyl cyclase, which is initially inactive. When it takes nitric oxide, it becomes active and changes the cyclic GMP. Now you know the role of cyclic GMP, the vasodilation effect. That's why nitric oxide retains its name, endothelium-derived relaxing factor. This event can be stimulated by cytokines, immunonephrosis factor, interleukins, and through exercise. Nitric oxide can be grouped under nitrogen-centered radicals, and it's named as endothelium-derived relaxing factor. It can be generated by, or can be synthesized by nitric oxide synthase from L-arginine. Its function, vascular functions, can antiplatelet aggregation, can be useful as immune response, can act as neurotransmitters. If the amount of nitric oxide which is produced by 2 enzymes, their amount is very low, or the amount is produced when what the cell needs. Whereas in inducible nitric oxide, the amount of production of nitric oxide concentration is very high. Okay? It's not controllable, and that leads to cytotoxicity. And when nitric oxide reacts with superoxides, it can able to generate a peroxynitride. That means during the early phase of atherosclerosis or heart disease, the amount of nitric oxide in your body becomes what? Less than expected. Because superoxides, that means whenever there is oxidative stress, these superoxides react with nitric oxide, it will form peroxynitride. Now the concentration of nitric oxide becomes what? Decrease. Once the concentration of nitric oxide decreases, there is no more vasodilation effect of nitric oxide. That's the first event of atherosclerosis. This is how nitric oxide can be produced. Okay? If there is absence of L-arginine in the biopsy, nitric oxide also can able to generate other form of reactive oxygen species like superoxide anions and hydrogen peroxides. This is a function of nitric oxide. Okay, those enzymes which are calcium dependent, it can change L-arginine into nitric oxide and citrulline is produced in this case as well. This cytosolic nitric oxide, that's the calcium dependent one, C, okay, indicates calcium dependent, contains L-arginine into nitric oxide. Whereas inducible nitric oxide, their activity is calcium independent, okay. Calcium will not affect the activity of inducible nitric oxide. Rather, their activities depend on at transcription level, okay, at gene transcription level. And some cytokines may enhance what? May enhance the activity of inducible nitric oxide synthase at gene level. That enhance the production of large amount of inducible nitric oxide synthase messenger RNA that enhance translation and we look for large amount of nitric oxide synthase, large amount of nitric oxide can be generated. And this nitric oxide can have its own role, can act as stimulus cell activities, antimicrobial effects, can be involved in cellular addition, or through soluble guanylyl cyclase, it will have vasorelaxation effect, or can have its own antiplatelet aggregation effect. Now, as summary, when you see the action of nitric oxide free radicals, it dilates blood vessels. It also reduces the oxidation of LDL cholesterol. Okay. As you know, one of the major events of atherosclerosis plaque formation, LDL should be changed into what? Oxidized LDL. And this oxidized LDL can be ingested by macrophages, unlimited. Now, the presence of nitric oxide can reduce what? The oxidation of LDL. That's why. If you don't have enough amount of nitric oxide, you will have less chance to develop atherosclerosis. If the percentage of nitric oxide is less, there is high oxidation of LDL, and it will be changed into oxidized form of LDL. This oxidized form of LDL is engulfed by macrophages. You will have high prone to develop atherosclerosis. The presence of nitric oxide also dilates blood vessels. Okay, but if there is low in amount of nitric oxide concentration in your body, you will have high chance to develop hypertension, since your blood will not dilate enough. The other is nitric oxide also, it's very important to reduce the release of superoxide radicals, okay? Because the presence of nitric oxide reduces the release of superoxide radicals. And the other is, it can also reduce monocyte stiffness. It can also reduce platelet stiffness as well. Now, a summary: if you have enough amount of nitric oxide, your blood will dilate and can be synthesized by 3 enzymes. But inducible nitric oxide can generate large amount of nitric oxides in your bodies. Now, when nitric oxide reacts with superoxides, it can generate another form of reactive oxygen species called peroxynitrite. Now, this peroxynitrite is grouped under oxygen-centered species or nitrogen-centered species, or in both. Peroxynitrite, where it is grouped? Is it grouped under oxygen-centered species or nitrogen-centered species? Peroxynitrite, this type of reactive species is named as reactive nitrogen-oxygen species. We can say like this. This has both oxygen and nitrogen. It's produced when nitric oxide reacts with superoxides. Because of its ionizing properties, peroxynitrites can damage a wide array of biomolecules, can affect our cells, can affect our DNA, our proteins, our mitochondria, and so on. The higher the amount of peroxynitrite, the higher programmed cell death, or there is high amount of apoptosis or necrosis. but its mechanism is concentration dependent mainly. Okay, peroxynitrite enhance lipid peroxidation, protein oxidation, protein nitrate, and when proteins will undergo oxidation means those amino acids residues can undergo what? Oxidation. And enzymes are proteins. Now, due to this reason, the presence of peroxynitrite inactivates what? The activity of enzymes. This leads to necrosis. In some cases, peroxynitrite also enhance the release of cytochrome C. That means it can enhance what? Caspase activation or apoptosis. Now, summary, peroxynitrite are responsible for many cytotoxic effects. Can enhance lipid peroxidation. Even the concentration of glutathione can be depleted, since the presence of peroxynitrite enhances oxidation of glutathione. Even it can inhibit some enzymes like peroxidase dismutase. Okay? Even peroxynitrite affects our DNA by nitrosylation, deamination, oxidation, and so on. Mainly, you have to know here the effect of peroxynitrite is concentration dependent. The higher concentration of peroxynitrite enhance necrosis, whereas the low amount of peroxynitrite activates apoptosis. And this is how the peroxides and peroxynitrite will interact together to form different effects. For example, the peroxides and peroxynitrite, both of them enhance what? Lipid peroxidation. Both of them enhance DNA damage. Whereas superoxides will have chemotactic agents. It will have also enhance the activation of nuclear factor kappa B transcriptions. It also enhance addition molecules. Whereas peroxynitrite, it enhances cell death by necrosis or apoptosis, or it may inhibit specific enzyme activation. But how peroxynitrite is produced? When nitroxide interacts with the peroxides. And these are some of the biomarkers to indicate reactive oxygen species. When there is high amount of reactive oxygen species, if it affects carbohydrate, there will have what? Advanced in glycated molecules. And the advanced in the glycated molecules can act as what? A biomarker to indicate there is high amount of reactive oxygen species, and this affects carbohydrates. If there is high amount of malonyl, that is a biomarker to indicate large amount of reactive oxygen species, which affects what? Our lipids. If in the case of proteins, if there is high amount of oxidative stress, there is what? Protein carbonates. And protein carbonates can act as what? A marker to indicate high amount of oxidative stress. 8-hydroxyl-deoxyguanosine indicates a biomarker to indicate our DNA is highly damaged by oxidative. That's all for source of free radicals and type of free radicals. After tea break, we'll see antioxidants. For the time being, I think this is enough. ከሻይ ቡና በኋላ እንገናኝ ይሻላል።
ይሻላል። አንድ ትንሽ በቃ እስከዛ ድረስ ጥያቄውን እንጻፉና
ጻፉ። እስከዛ ጥያቄ ካላችሁ
ስንት ሰዓት እንገናኝ?
አሁን ኦልሞስት 5 ሰዓት ነው። 5 ከሩብ 5 አካባቢ።
እሺ 5 ከሩብ እንገናኝ።
Medium, ያዝኛው ከሞላ ዞናል ናናን ነው ኮንሲደር ያደርጋል እንግዲህ ከተመረጠ ነበር ይላል ያ ያ ነው ብሎኛል አረፈም እንትን ይሄን በስኩት ላይ ወሬ ዛጋሙ ነው እንትን ትለኝ አልገባኝም ነበር report ሙዚቅ ኮር ጀምሬያለሁ ዛሬ ምናምን ገደሻለሁ እንግዲህ ከሞላ ወይስ ገና ምናምን ሀያ ስልክ ሰላም እንግዲህ Indonesia online juga ya belum ada sermat dari minggu rumah kemarin yang mengantar Indonesia juga kali jadi kemarin ke apa dan writing itu berbeda लेकिन मौजूद में जो तकल मौजूद राशि आसाम से हम जानो राशि से ग्रेड है वाला फिर क्या कहना ग्रेड लाता है आई डोंट ग्रेड अने लास्ट अभी करना पड़ा मार्क लाख लिस्ट निकाल के पाएंगे मार्क कमाना ग्रेड मात्र देखो ये नहीं देखो लाख लिस्ट ग्रेड ऐसा No, original ግን ተመላሽ ነው በግሪድ የነበረ ግን በግሪድ አይደለም የሚለው ስምትላቸው በሚዲያክሪ ዲፓርትመንት እኔ እንሳይ ፋርት ግሪድ ይልክም ማለት ነው ለታለው ለና አለኩ ለናንተ ሌላኩኝ ዲፓርትመንት ይዘ ስለዚህ ይኬ ነበረ ለነሱ አላኩ ግን ላክልን ሲሉ ዲፓርትመንት ላይ ላሰድክ ነው ግሬድ ስላቸው በግሬድ አይደለም የሚገባው በማርክ ነው ማርኩ ይቀየራል ወደ 15% ሌሎች ሞጁሎች አሉ ሌሎች ኮርሶች አሉ አይደል አናቶሚ ፊዚዮሎጂ ምናምን ራሳቸውን የቻሉ ኮርሶች ናቸውና ፋውንዴሽን ኦፍ ሚድዋይፈሪ ዋን ይላል ሞጁል እዛ ውስጥ ነው የሚገባው እንጂ ራሱን ትምህርት ይገባል ኬሚስትሪ will not be submitted alone as one subject for approval, but in marks, not in grade. Because biochemistry has such a subject allowed to be grade. Rather, እንደዛ ነገር ታውቃለህ ልክ እንደ ነርስ ምናምን እንዳነስያ ነው የሚለየው ምንድነው ኢንዲቪጁዋል ከመቶ አስከተሉ ገባል ከዛ በኋላ ማርክ ሰብስበውና እነሱ ነው ፋውንዴሽን ሚድዋይፈሪ ዋን አንተ ነው ተደምሮ ከመቶ እነሱ ነው ከመቶ ልክላቸው ስለዚህ ዳያው ቴሌፎን ኮድ ታውቃላችሁ ራሱ ኮድ ነው እኔ ከመቶ ብቻ መላክ ነው ማፕ ከመቶ ልክላቸው ነው እነሱ ተከምተው 15 ምናምን ይይሩ ያልታቸው እንደ ማስማስ 10 ማት ነው ይችላል ያለች ማሪያው ምንጣት እንዴ አንተ ታውቃለህ ነው Como por isso, passou por já, e aí fica na rua, ያለው ማካንት ሰማንታት እንዳለው ነው ወደ መቶ መቀየር እንደው ይቻላል ያመጣል እነሱ ላይ ሶስት ማካንት ነው እነሱ ነው ዝምብራቸው ዝም ብሎ ወደ ሰማንታት ወደ መቶ መቀየር ይቻላል ያመጣል ታዲያ ነስማ ቆይ ነሲ ስሩ ጀምራሉ ጀገና ጀምሩ ነው ሞጁላር ሆኖ በፊት ያማ ያኛ ሞጁላር ያው 50 አፍነት ይልካለ ሞጁላር ይሽልሽ ስማ አቀለፍ ተናካለ እኮ ሳሚት ማለት ነው ቶኒ ለማ ትንሽ ማርኬት ነው አጥያቄ ነው የአንተ ስንት ተናካልኩ ማለት ነው ሞጁል ነው Module 2 class started I will teach this August month from start every Wednesday every Wednesday roll ማለት ነው መጥያው ነው ሮብ ሐሙስ ዓርብ አለ ሁሉ ሮብ ሐሙስ ዓርብ ሁሉ ዴይ ኦገስት መንዝ ብቻ ያለ ነገር ነው አጥቷት ለምሳሌ ጨርሷል ነው የምትለው እሱ ነገር ሳይሙ ቢፎር ትናንትና ዛሬ ቢፎር was finished basic concept basic concept simple Dato. Dato. Io nel chicken ballo con la brada si ci da fare nella brada non chicken non hanno allora no window ነው አልጫውኩም እሱ window ማ ትኛለህ ዲስክሬን እንጂ በዚህ ኦክስፎርድ ባንክ ለቋንቋ ፈልጌ ነው እሱ ወደ አማርኛ ቢሆን ካለም ችግር የለውም። አንዳንድ አሁን ከተለመዱ ምግብ ማርቆስ ዋፓስ ነበር የምን ነው ዋፓ ዛሬ በጣም ነው የሚበላ ተማሪዎች
እስኪ ለነገ ሪፖርት ንገረኝ። አንተን ጉዳይ አላነሳም። ምን አለ ማለት ሚቲንግ ላይ ምንም ካሪያስ ምንም አላነሳም። ስንሰን ጠይቃለሁ ሌሎች ምን አለ ይሾ አለ
ግሬድ አፕሮቫል
ግሬድ ሰሚት አለ ዋልብን እንትን በኤግዛም ተቻንትና አይነን ግባለ እና በቆርጥ ኮንዳለ
ያቆም መልስ
ገባና እንትን ገዳ
በዛው ላይ ኮንት
አንተ አፍሪካና እንትና ኢንዶክትሪን ማለት ነው።
ኢንዶክትሪን እንዴት ይደረጋል? እንዴት ነገ ነው እሱን ከተማ ኢንዶክትሪን ነገ ነው ለኤን ሞጁል 3
ሞጁል ስንት ነው ኢንዶክትሪን?
ሞጁል 3 ነገ ነው
ሞጁል 4 5 አይደል ያልከኝ ብለህ ምንድን ነው የምን ሞጁል ስለሆነ
ሞጁል 3 ኛስ
ምንድን ነው እናንተ ሞጁል
ባዮኬሚስትሪ ነው እና ሞጁል ነው ኢንዶክትሪን ነው
ኢንዶክሪኖሎጂ እኮ ነው ሞጁል ስንት ነው?
ኢንዶክሪኖሎጂ ማስተማር ነው እኮ ስታንት ነው ኧረ የምልህ እኔ ሞጁል 3 ኛ ሳይ ኮርስ የሚያደርገው ሞጁል አለ አይደል ሆሞስታስ
የላቦቹ ምናምን
ነገ ነው
ዛሬ ነበርኩ ፖስትፖንድ እዚህ የኢንዶክሪኖሎጂ ዛሬ የተባለውን ለነገ ነው ያው እሱ እንዲፈተን ነው
ምኑ ይኸው በአሁን እንደጨረስኩ እልክልሃለሁ። የለውም ተመቻች ጥያቄ ምናምንስ የባለፈው ሞት ላስተማርኩት ጥያቄ ሲወጣ ምናምን ባለፈው ሞት ላስተማርኩት ነበር አይደል? ጀነራል ምናምን ጥያቄ ፋይናል ኤግዛም ሲመጣ ምናምን ጥሩ ነው አይደል? ጥያቄዎች ሄሎ እንጀምር
እንጀምር
Okay, the final part for this session is antioxidants. Okay, we will see antioxidants based on their sources. Can be exogenous or endogenous, or it can be enzymatic or non-enzymatic. We will see later the type of antioxidants. Now, first, let's see the definition of antioxidants. Meaning can depend on the context. Okay, antioxidants are a substance which is present in low concentration compared with that of pro-oxidants or oxidizable substrates, and it can inhibit what? The oxidation of the substrate. This is the definition of an antioxidant. Whereas pro-oxidant is any substance or any species that promotes what? Oxidation. The opposite of this is called an antioxidant. But depending on the circumstance, a compound may exhibit pro or antioxidant activity. Sometimes it depends on the oxygen tension. Okay. Example: phenols, thiols, alpha-tocopherols. Depending on the oxygen concentration within our bodies, it can act as pro-oxidant or can act as an antioxidant. Sometimes it may promote oxidation, or it may inhibit formation of reactive oxygen species. Now, let's see now some of the function of Antioxidants. Antioxidants can destroy free radical damage, or it can promote growth of healthy cells, or it may protect our cells from aging. It may fight age-related macular degeneration. It provides excellent support for our body immune systems. Therefore, no matter whatever your age, you should take what? An antioxidant. Some of them, even if some of them is endogenous, okay, that is not enough to scavenge or to reduce the effect of reactive oxygen species. Because always through electron transport oxidation, okay, 1 up to 4% of oxygen is changed into free radical formation. Therefore, always there is production of free radical formations. We need to limit its concentration. If the concentration of reactive oxygen is higher than the normal, it will have a damaging effect for our bodies. These are some of the important aspects of or role of antioxidants. It can improve our sleep, can support respiratory systems, it can able to reduce obesity, it can protect our livers, because liver is the main organ which expects to detoxify xenobiotics. Now, in phase 1 xenobiotics, there is production of what? Free radicals. The higher free radical production within the liver, it affects our liver function. Therefore, taking enough amount of antioxidants can protect our liver. It can improve our nervous system. It can support our immune systems. It also supports what? Our kidney. As you know, within the kidney also there is what? Detoxification. Now, what is the criteria to say an antioxidant is a good or an ideal antioxidant? Some of them may not fulfill all of the criteria, but to be an ideal antioxidant, first criteria is no harmful effect for our body. Second, it should be effective at low concentration, and it should be fat soluble, and it should be readily available, and it will not contribute an objective flavor or odor or color to the fat. Now we do have natural antioxidants and we do have synthetic antioxidants. The natural antioxidants, like for example, ascorbic acid, it's a vitamin C. Now here you should know also the location where antioxidants are effective. For example, if you see vitamin C, since it is water-soluble vitamin, it will not be effective to limit the free radical effect on plasma membrane. Okay, the location is very important. Vitamin C, it's an antioxidant compound. Vitamin E, it is fat soluble, yeah. Okay. So as I mentioned earlier, some of them may fulfill some criteria, but not all. Vitamin E is fat soluble vitamins, phenolic compounds, okay, flavonoids, carotenoids, vitamin A. Mainly the lycopene, okay? It's part of carotenoids, which has its own great role as an antioxidant. Synthetic ones, like butyl hydroxide anisole, butyl hydroxidol, chlorophyll, garlic, and so on, can act as synthetic antioxidants. Now, how we will counteract those reactive oxygen species which is produced in our body? We do have two mechanisms to reduce the harmful effect of reactive oxygen species. One is through enzymatic actions, like glutathione peroxidase, peroxidase dismutase, and catalase. These are enzymes which limit the effect of reactive oxygen species. The other is antioxidants, like stable molecules which are able to donate electrons, like glutathione, ubiquinol, uric acid. You know uric acid, okay? Can act as an antioxidant. Vitamin A, C, E. Vitamin A is sometimes it is a controversial actually, but it can act as an antioxidant. Now, what are the mechanisms? How antioxidants may protect from reactive oxygen species? One is prevention of formation of free radicals. Some antibiotics prevents formation of free radicals at initiation stage. The other antioxidants can intercept once even free radicals are formed. And the others will enhance those enzymes which are intended to repair the damage which is caused by reactive oxygen species. And the other antioxidants may provide favorable environment. Okay. Now this is a major role of antioxidants. Okay. Some of them can have an anti-aging benefits. It enhances body natural defense. Finally, if you do have enough amount of antioxidants, you will improve your immune function and you will have low risk of developing infection and cancer. When this is antioxidant classification, based on functions, some antioxidants are free radical scavengers. Okay, scavenge the free radicals like ascorbic acid. It can scavenge non-radical oxidants like catalysts, for example, which scavenge what? Hydrogen peroxide, thiols, which scavenge hypochlorous acids. Compounds that inhibit generation of oxidants. You know the role of transition metals. The transition metals should be what? Sequestered within the protein. If it is freely found or if it escapes from that protein, it will enhance formation of generation of free radicals. Now, those compounds which inhibit oxidants, like transition metals, are like metal chelators. Compounds that inhibit, that induce the production of antioxidants. Okay? These are some of the classification of antioxidants based on their functions. Now, here in this table, we will see these are some of reactive oxygen species list and their counteracting antioxidants. For example, singlet oxygen. Their antioxidant is vitamin A and the vitamin superoxides. Their antioxidants are enzymes like superoxide dismutase and vitamin C, and so. Now, here in hydroxyl radical, okay, their specific antioxidant is vitamins. Now, vitamin E is a good antioxidant. It's a good antioxidant, but there is limitation of action because since it is fat-soluble vitamins, okay, more reactive oxygen species can be generated in aqueous phase rather than on liquid phase. Antioxidant classification, structurally, can be enzymatic or it can be small molecule. Locality, it can be water-soluble or lipophilic. Now, classification can be different types based on mode of action, location, solubility, origin, likewise. Now, first, let's see according to types. Antioxidants can be enzymatic or non-enzymatic. Enzymatic, like superoxide dismutase. Non-enzymatic can be two types, nutrient or non-nutrient. For example, nutrient types, alpha-tocopherols, okay? Beta-carotenes. Alpha-tocopherols is a synonymous name of vitamin A, okay, like gamma-tocopherols and so. Beta-carotenes, vitamin C, selenium. Non-enzymatic antioxidants like seroplasmin, transferrin, uric acid, and so. These are some of the classification of antioxidants. It can be enzymatic or it can be non-enzymatic. Enzymatic antioxidants, especially, for example, primary enzymes like sodium, like superoxide dismutase, catalase, glutathione peroxidase. Now, here, for example, glutathione peroxidase utilize what? Glutathione, reduced form, GSH. And it will be changed into what? GSSG. But once GSSG is formed, again to use glutathione, GSSG should be recycled to what? GSH through NADPH. And NADPH is mainly produced by pentose phosphate pathways. Pentose phosphate pathways. And to do that, we need to have what? An enzyme called glutathione 6-phosphate dehydrogenase. And this enzyme is useful as or classified as secondary enzyme or enzymatic antioxidants, but it's considered as secondary enzymes. Based on mode of actions, antioxidants can be preventive or it can be scavenging. Preventive enzymes like superoxide dismutase, catalase, glutathione, methylone sequesters like carotenoids, superoxide dismutase, and so on. Scavenging like vitamin C. Okay? Therefore, based on their mode of actions, antioxidants can be classified as preventive antioxidants. That means preventive antioxidants, its major role is what? To reduce the rate of chain initiation. It blocks formation of free radicals. The other group is chain-breaking antioxidants. It can interfere what? Chain propagation. Once free radicals are generated, it will interfere its propagation to another form of reactive oxygen, like urate, vitamin E, and so on. Based on locations, it can be intracellular, like superoxide dismutase 1, 2, catalase, and so on. Extracellular, actually, superoxide dismutase can be found in 3 isoforms. Superoxide dismutase 1, 2, 3, and their location can vary. Okay, superoxide dismutase 3 can be found extracellularly, for example. Uric acid also is important antioxidant which act as extracellular membrane activated, like vitamin E. Okay, alpha tocopherols can act as a good antioxidant. Solubility, as I mentioned earlier, based on whether it is the antioxidant soluble in water or not. Water soluble, like formic acid, uric acid, and so on. Lipid soluble, like vitamin E. Now, some antioxidants can be classified based on structures they protect. Those antioxidants which protect our DNA are the following, like HODOR, 2, glutathione peroxidase, and so on. Those antioxidants which protects our proteins are like its role will be what? Sequestration of transition metals by preventive antioxidants. Preventive antioxidants sequesters what? Transition metals, and that limits formation of pentoene reactives. And the other antioxidants which protects our lipids are like vitamin E, okay, as vitamin C. Vitamin C here will have an indirect role to protect our lipids in order to recycle the alpha tocopherols. Now, based on their origin, antioxidants can be exogenous or it can be endogenous. Exogenous source, we can get it from the food what we eat, like carotenoids, ascorbic acid. As you know, vitamins will not be synthesized in our body. Tocopherols, polyphenol, and so on. Endogenous, those enzyme antioxidants are considered as endogenous antioxidants. Let's see one by one. Roughly. For example, ascorbic acid. It is scavenging water soluble. Its sources are like citrus fruits. It can scavenge water soluble peroxide, hypochlorous acid, singlet oxygen, and so on. It also decreases heavy breakdown by preventing pentoene reactives. Ascorbic acid can also protect our lipids, but its role is indirect, as I mentioned earlier. This is because it reforms what? Alpha tocopherol from its radicals. Once alpha tocopherols donates its electron to the free radicals, okay, it will form alpha tocopherol radical form. This alpha tocopherol radical form can be recycled to the original ones by vitamins. It protects against reactive oxygen species released from cigarette smokers. If you know how much ascorbic acid is needed daily as an antioxidant, those who will smoke cigarette will take too much or higher than the normal one, because smoking cigarette decreases the concentration of vitamin C. This is how our ascorbic acid can be recycled in our bodies. The other is vitamin E. Okay? Sources are like unsaturated fat like sunflower and olive, whole wheat flour, and so on. This is the most important and effectively soluble antioxidant. It is important for maintaining the function of plasma membrane. But it should require what? Another antioxidant species to recycle it, like coenzyme Q, ascorbic acid, and so on. And the amount of vitamin E, just like that of vitamin C, is compressed for smokers. For those who smoke cigarette, will take what? An amount of vitamin E and vitamin C. And the vitamin E possesses anti-inflammatory and antioxidant properties. Vitamin E also inhibits what? The activity of protein kinase C and subsequent platelet aggregation. It also inhibition of nitric oxide production by vascular endothelium. It also inhibits what? Superoxide production by macrophages and neutrophils. But as I mentioned earlier, the solubility of specific antioxidants limits its action. The limitation of antioxidants are as a result of limited mobility within the cell membrane. It lacks water solubility. As I mentioned earlier, many forms of reactive oxygen species can be generated in aqueous phase. And vitamin E possesses anti-inflammatory properties, okay, and antioxidant properties. It inhibits what? Superoxide production. Carotenoids, sources like deep orange, red, yellow, fruits, and so on. Among these, lycopene, like tomatoes, okay? Lycopene, its antioxidant activity is 2 times as great as carotenes. And cooked tomatoes are better than raw ones. And taking enough amount of tomatoes will protect ourselves from different cancers like prostate, lung, stomach, and so on. Actually, the other antioxidant is vitamin A. Or actually, it's vitamin A as a mineral. This is controversial. Some come act as an antioxidant, or some midwives say vitamin A can act as an antioxidant. But behavior depends on the oxygenation of the immediate environment. At low partial pressure, vitamin A can act as a good antioxidant. At higher concentration oxygentations, vitamin A enhances what? Or it promotes oxidation. That means vitamin A can act as a pro-oxidant behavior at higher oxygen tensions. The other is polyphenols or flavonoids. This can be found in vegetables, red wine, tea, and so on. It can act as radical scavenger. It also terminates lipid propagation. It also acts as metal chelators. Okay. Other sources of antioxidants can be found in honey, green tea. Okay, these are good antioxidants as well. Finally, we will see uric acids. This uric acid is the major radical scavenger within the plasma, urine, and saliva. Scavenging singlet oxygen, hydroxyl radical, hypochlorous acids, and so on. The other is glutathione. It is tripeptide. It's non-essential tripeptide since it is synthesized in our bodies. It can act as radical scavenger. Okay. It also regulates interleukin to dependent T lymphocyte proliferations. The major function of glutathione is that it maintains the intracellular redox balance. Okay, the major function of reduced glutathione, that is GSH, is it is very important to maintain the intracellular redox balance. And you should know how smoking affects our health. Okay, individuals which smoke more than 10 cigarettes per day will have high chance of developing heart disease, will have high risk to develop any form of coronary heart disease. Whereas, even if smoking a single cigarette significantly reduces salivary and plasma glutathione, you should know this one. The other is enzymes like superoxide dismutase, as I mentioned earlier. It's localized within the human and important mechanisms, and it's found in different body parts, locations. For example, peroxide dismutase 1, it's copper zinc dependent enzyme, and which is found within the cytosol. Whereas peroxide dismutase 2, it's manganese dependent enzyme, which is found in the mitochondria. Whereas SOD3, it is found in extracellular. Now, what is expected from you is that you should know where antioxidants can act. Antioxidants act in different ways. What is effective against one oxidant may not be ineffective against another. Now, localization is very important. Compounds may enhance antioxidant capacity of cells, but it may be ineffective in test tube assays. You need to know your oxidant. As you know, reactive oxygenous species is not an entity. Reactive species are what? Individuals. And this is the approximate plasma concentration of antioxidants, what we be expected to take. Now, these are some of the biological antioxidant different mechanisms in specific positions. Okay? For example, some antioxidants may be important to sequester transition metals like ferritin, transferrin, ferroplasmin, ferromalbumin. Some antioxidants can act as free radical scavengers like vitamin E, reduced vitamin C in high concentration, and so this is where free radicals can be produced. At that positions, these are the corresponding antioxidants which protects our cells from reactive oxygen species. In our mitochondria, we do have different enzymes which protects the function or production of interests of reactive oxygen species within the mitochondria. Let's see one by one. Let's see some of the mitochondrial localized antioxidants. One is manganese superoxide dismutase, that is SOD2. This catalyzes what? Formation of reactive oxygen species, mainly superoxides, mainly hydrogen peroxides. Once hydrogen peroxides are formed by catalysis or glutathione peroxidase, can be changed into another forms. But here, this enzyme is exclusively in matrix of mitochondria, and large percentage of tumor cells will have a low amount of this enzyme activity. The other is copper or zinc dismutase. It catalyzes the same reaction. Okay, primarily it's found in cytoplasm, but also present in the mitochondria. Mechanism transport to the mitochondria is somewhat it's unknown, but mutant form of SOD1 will be associated with what? Amyotrophic lateral sclerosis. Okay. Glutathione, as I mentioned earlier, can be used as an antioxidant within the mitochondria. The other is glutathione peroxidase. It's also important within the mitochondria. Cytochrome C, also it's very important to scavenge superradicals. peroxidireducing, pyrodox. These are some of the antioxidants which will have a role in mitochondria. Exogenous mitochondria have target antioxidants. These are antioxidant compounds that are physiological. And so this is what is amyloid lateral sclerosis. This is caused by what? A mutant form of SOD1, not SOD2. These are additional slides or optional slides. If you need, you can use. Okay? But the session is over. ጥያቄ ካላችሁ የዛሬው ጨርሰናል። These are optional slides. If you want it, you can use it. Okay. ሰማት ጥያቄ ካላችሁ
አንድ ትንሽ አንድ ቀን ተጠቅቀን
እሺ እልክልሃለሁ አሁን
እሺ
ጥያቄ ብቻ ልመልስላችሁ። በእንትና የሚጠይቅ ደግሞ በዚህ በጽሁፍ ልመልስ። Absolutely. Electric transportation na. So, generate compressive. Generate compressive. Electric level compressive. Le finite level. Le next exam. Next exam no? Oxygen mass ፈልጋል አንተ ያየ ባዮኬሚስትሪ ተምረው ዜኖባዮቲክ ካልተፈተኑ በቃ አልተማሩም ኮርስ ሞጁል እኔ እኮ ዜኖባዮቲክ በማስተማሪ እዚህ ላይ እንዴት እንደቀለለ ልነግር አልችልም።
Hello, Sensei. Hello. Hello. ይሰማል? ምናምን ብያቸዋለሁ ማላብራራለት
ይሰማችኋል? ሄሎ
ይሰማል።
okay, yeah, non-radicals are toxic just like that of free radicals because, for example, hydrogen peroxide, it is a non-radical, but when it interacts to iron, ferrous form, it can able to generate what? Hydroxyl radicals. Okay, now hydroxyl radicals are the most toxic free radical forms. Okay, the other is peroxyl radicals. Okay, peroxyl radicals can be generated when two free radicals, that is nitric oxide and peroxides, can able to react to form peroxynitride. It's an example of a radical, but it's as toxic. Now, what you know is that toxicities depend on what? The life span of the free radical. Okay, but the first criteria to say reactive oxygen species is toxic or not, the more the toxic, the more redox potential. Okay, the higher the toxicity, the more reductive potential. That means hydroxyl radicals will have high redox potential than the rest reactive oxygen species, and that is the most toxic ones. Okay, but non-radicals also toxic like that of antioxidants. Why? This is because it can regenerate other free radical initiation or other free radical propagations. Okay? That is why non-radicals are also toxic like that of free radicals. Have you seen this peroxynitrate, how much it is toxic? Okay. Criteria is the more the toxic, the more redox potential. I will show the picture, okay? Toxicity will be enhanced once there will have what? High redox potential. Have you seen the reduction potential? Reduction potential ያው ምላችሁ ባለፈው ሞጁል ላይ ስላየ ነው። Its role, the more the redox potential here, the more toxic of the reactive oxygen species. Here, peroxynitride, for example. Okay? As I mentioned earlier, hydrogen peroxide is not a free radical. Peroxynitride, which is formed when superoxide reacts with what? Nitric oxide. Peroxynitride will have its own role in apoptosis as well as necrosis, but it is concentration dependent. And it is a strong oxidizing agent that is not a free radical actually, but it can generate nitrogen dioxide, which is a radical again. Now, the more the redox potential, the more harmful free radicals can be generated. But non-radicals or non-free radicals are also toxic like that of free radicals. Example, hydrogen peroxide and peroxynitride. Because hydrogen peroxide reacts with iron, it can able to form what? Hydroxyl radicals, another reactive oxygen species. ተመለሰላችሁ? ናቲ
ተመልሷል።
እሺ በቃ ላክላ አሁን።
በቃ ላክልኝ። እሱንም ይሄ ፓወርፖይንትን ቪዲዮ ነው።
እሺ እሺ ቻው፣ ሰላም ዋሉ። ነገ እንገናኝ።
ቴንክ ዩ
ነው እኔ ፈተናቸው ነው አረብ